Hello, I welcome you all to this another interesting screencast. The problem reads, determine the magnitude of the resultant force in this direction measured counterclockwise from the positive x-axis. Counterclockwise, right? Counterclockwise like that. Okay, counterclockwise. Okay, from the positive x-axis. So this problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. We're going to tackle this particular problem using two methods. One method, we're going to use the parallelogram. Okay. And then the other method, we're going to use resolving this into x and y components. All right. So let's begin. So we have two forces here, 800 and 600. So let's say this is F1, this is F2. All right, F1 is equal to 800 newtons and F2 is equal to 600 newtons. Right. Let me just take this a little bit down. So I was saying this is F1 and this is F2. All right. So like we said, we are using the parallelogram law. Parallelogram. Okay. This is the parallelogram method. Right. There we go. Let me just underline. Right. So what we'll do first things first, let's draw the parallelogram. Let's draw the parallelogram. So I'm drawing this particular vector which is parallel to F2 and it will have the same magnitude as F2. Okay. And just screen it up a little bit there so that 800 is visible. So this is F2. Okay. And then I'll draw another one from this point. This one is parallel to F1 like so. Okay, maybe this one I'll need to write the arrows properly. Let me write the arrows properly. All right, something like that. Okay, great. So we said this one is equal to, this is F2, this is F2. Okay, so there we go. And then we are going to have the resultant. We'll have the resultant somewhere there like so. All right, and this is equal to FR. Okay, great. So we have drawn the parallelogram. So we have this top triangle and the bottom triangle. We can use any of those. They have the same properties. So what we're interested in now is to add more details to this parallelogram, to the triangle that we've chosen. So let's choose the top one. So we're going to use the top one. So we need the angles, the internal angles inside those triangles. All right, so what we have, so for F1, okay, F1, there we go. Sorry, this is F1 here. How did I write F? This is F1. Okay, so for F1 it is 90 degrees with respect to the x-axis, and then for F2 it is 30 degrees. So we can transfer this angle. We can transfer this angle here. So let's draw a coordinate system. We draw another coordinate system there like this. All right. Okay. So if we do so, then we know that this angle here, okay, this angle here is equal to, this one here, 30, right? Do you agree? This is 30 degrees. So if this is 30, then we know what this is, right? What is this? Tell me. It is because this whole lot of this is what? Is 90. So this is just going to be equal to 90 minus 30, which is equal to 60, right? Great. So this is 60 degrees. Okay. This is a 60 degrees. So we have this angle here, which is enough for us to start doing the work, right? So we can use the parallelogram law to find FR, and once we found FR, we also need another angle. We need this angle here measured from there. So this is the angle we need. We need this angle. This will be the direction. This is our theta. Okay. So for us to find that, we will need to find this one here. We'll need to find this angle here. Okay. So that we subtract from 90. So this angle, we're going to call it alpha. All right. Great. So let's go ahead. So using the cosine rule, FR is equal to square root of F1 squared plus F2 squared minus 2 times F1 times F2 cos which angle? The angle opposite FR is 60 degrees. Therefore, FR is just going to be equal to, we know what F1 is. F1 is 800, F2 is 600. So let's punch this in our calculator. So 800 squared plus 600 squared minus 2 by 800 by 600 cos 60 square root of that. It gives us a 721.11 newtons. You can repeat it. 800 squared plus 600 squared minus 2 by 800 by 600 cos 60 square root of that is 721.11. Great. So once we have that, then we need to find alpha. Once we found alpha, then we find theta, because we know that our theta measured counterclockwise from the positive x-axis is equal to 90 degrees minus alpha. We agree? Great. Therefore, using the sine law, we'll say sine alpha, okay, divided by F2 is going to be equal to sine 60 degrees divided by FR. And alpha, therefore, is just going to be equal to sine inverse of F2 sine 60 divided by FR. Okay. Alpha, therefore, is just going to be equal to F2. What is F2? F2 is 600 times sine 60. Okay. Divided by FR, which is 721.11. Alright, sine inverse of that, it gives us a 46.8 6.10 degrees. Okay, F2 is 600 sine 60 divided by FR, which is 721.11. Sine inverse of that is 46.10. Okay, so let's feed this. Let's feed this into this equation. They are like this. Once we do so, then we'll find that theta is just going to be equal to, as we are subtracting from 19, right? So we get a 43.90 degrees. Great. So we are done with the first method. So let's go to the second method, where we are going to be resolving the components for x and y. Components for f1 and f2 into x and y. So let's call this as method 2, which is by using the x and the y components. Okay, you can call it whatever name. All we are doing is just resolving these components, resolving the forces into its components. So let's draw the free body diagram. Let's start with F1. So let's call this as F1, which is 800, like we had called it in the previous case. So this is F1. Okay, and then this is F2. Alright, so F1 has only components in one direction, which is y. Then F2, it will have a component in this direction, in the x axis. Okay, it will have this component like so. It will have another component in the y axis, so in the x and in the y. So in the x, it is F2 cos 30, and then this one is F2 sine 30. Okay, so let's draw a table. So we have we have the x component in newtons, we have the y component in newtons. Great, there we go, something like so. Okay, so we draw the columns. Okay, and we only have two components, which is 1, 2, and another row for the summation. Great. So once we've done this, then let's start now summing them up. So we have F1, F2, and then the summation of the forces. So F1, the x component is 0. Okay, the y component is 800, right? F2, the x component is F2, and you, of course, F2. That is F2 is 600, so this is just going to be equal to 600 positive, 600 cos 30, and and then the y component is negative 600 sine 30. Okay, let's sum them up. We are summing the columns, these columns like this. Okay, so this is going to be 600 cos 30. This gives us a 519.6152. The reason I'm writing 4 decimal places is to just reserve my accuracy. The final answer will have 2 decimal places. So it's 519.6152. Then the other one is 800 minus 600 sine 30. Okay, so this one is just going to be equal to positive 500. So we have FRX equal to positive 519.6152 newtons, and we have FRY equal to 500 newtons. So let's draw this. Both of them are positive, so this looks like this. So we have something like this, something like that, right? Both are positive. Great. And then we have the resultant, which is going to be a bit closer to the x-axis, which is larger. Okay, not so large. Okay, great. So this is FR. Okay, and then this value, the x-axis, this is 519. No, sorry, this is the y-axis, which is 500. Then the x-axis is 519.6152 newtons. All right, and then we also need the angle which is measured with respect to the positive x-axis in the counterclockwise direction. So this angle here, okay, and this is our theta. Great. And it even matches there. We know to say tan theta is just equal to opposite over adjacent. Remember this in trigonometry? Great. All right, so let's find the resultant just using Pythagoras theorem. There we go. So here we have FRX squared plus FRY squared. Therefore, our FR is just going to be equal to, we know these values, let's plug them in. So 519.616152 squared plus 500 squared, square root of that just gives us a 721.11 newtons. Great. And then let's find what theta is. Theta is just going to be equal to tan inverse of FRY divided by FRX. Okay, and then theta therefore is just going to be equal to, both are positive, so 500 divided by 519.6152. okay, tan inverse of that just gives us a 43 point, round it off, this is 897, therefore it becomes 90 degrees. Okay, so the results seems they match and they're supposed to. So let's now just outline the final solution. In the first method, we have the resultant like so, okay, and we have the direction. This is by using the parallelogram law. In the second method, we have the resultant like so. We have the resultant. There we go. And we have theta like that. Okay, great. I think this is about it, and I hope the video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing, liking my channel. Bye bye, and see you in my next screencast.